Hey everyone, ever tried planning a multi-day trip? Juggling flights, hotels, restaurants, and activities. Now imagine doing that with AI agents. But here's the catch. When you ask an AI to plan something complex, it can get lost in details, make up information, or miss key constraints. That's where today's story comes in. So what's the problem? Large language models, LLMs, are amazing, but when tackling long-term tasks, like planning a trip with dozens of moving parts, they struggle. Why? Because they have to juggle huge amounts of information, rely on different tools, and keep track of interdependent constraints. And if they mess up even one detail, like a hotel name or flight time, it can derail the whole plan. Enter multi-agent systems, MAS. Think of them as a team of specialized AI agents working together. One agent might hunt for flights, another for hotels, and a third for restaurants. But here's the twist. Without good communication, these agents can end up working at cross purposes, or worse, creating hallucinations, where they invent fake details that don't exist. So how do you keep this team on track? Researchers at Carnegie Mellon University tested two key tools: a notebook for shared information and an orchestrator agent to manage coordination. Let's break it down. The notebook is like a shared digital whiteboard. Every agent writes down what they find: flight options, hotel availability, restaurant preferences, and everyone can access it. This stops agents from repeating work or contradicting each other. The orchestrator acts like a team leader, deciding who speaks next and when. Instead of a rigid script, it adapts in real time like a conductor guiding musicians. In their experiment, the team tested these tools against a benchmark called Travel Planner, which simulates complex travel planning. Without any tools, a single AI agent only succeeded 7.5% of the time. But with the notebook and orchestrator, the success rate jumped to 25%, a 17.5% improvement. Here's where it gets cool. The notebook cut hallucinations by 18%. For example, if an agent made up a hotel name, the notebook would flag it. The orchestrator then focused the team on tricky areas, reducing errors by another 13.5%. Together, they turned a shaky 7.5% success rate into a solid 25%. So what does this mean? It shows that structured teamwork, like a shared notebook and smart coordination, can make AI systems way better at handling complex, real-world tasks. Whether it's planning a trip, managing a project, or solving a puzzle, these tools could be the key to unlocking AI's full potential. But here's the deeper insight. Traditional AI workflows are rigid. They follow a fixed path like a checklist. If a constraint changes, say a restaurant is closed, the system can't backtrack. It's like a road trip where you can't adjust your route. The orchestrator, however, acts as a dynamic project manager. It doesn't just follow rules, it rethinks them. Let's dive into the numbers. When the team compared the old fixed workflow to the orchestrator-led system, errors dropped dramatically. For flight numbers alone, the new system cut errors by over 50%. Why? Because agents could double-check facts in the notebook instead of guessing. And when constraints conflicted, like a pricey restaurant pushing the budget, the orchestrator could backtrack, find cheaper flights, and keep the plan on track. But here's the twist. Even though the new system was more flexible, it didn't always deliver a plan. The delivery rate dropped slightly compared to the old method. Why? Because the orchestrator was more selective. It didn't settle for a plan that barely worked, it chased perfection. And when it did succeed, those plans were way better. Think of it like a chef who refuses to serve a half-baked dish. The final product is flawless, even if it takes longer. We also pitted this system against a single-A approach. Spoiler, the multi-agent team smashed the single agent. The multi-agent system delivered plans that satisfied more constraints, especially in tricky areas like transportation and hotels. Sure, it had more revisits to experts, but those revisits paid off by catching errors early. Now let's talk about the real-world chaos AI faces. Researchers tested the system in a sandbox environment, simulating trip planning without real-world consequences. But even here, errors popped up. The study categorized these mistakes into key areas: accommodation, restaurants, attractions, and transportation. Take hotels, for example. An AI might suggest a place that doesn't fit the budget, or has rules the user didn't agree to. Or it could pick a restaurant in a city where the user isn't even staying. These aren't just typos, they're gaps in the AI's understanding of real-world constraints. To fix this, the team created detailed system prompts to guide the AI. Think of these as cheat sheets for the agents. For transportation, the AI gets instructions to plan flights, adjust cities if needed, and check for reasonable routes. For hotels, it must list exact names, count nights, and double-check each property's requirements. Here's where it gets cool. The AI doesn't just guess. It uses tools, like a flight search function to find available dates, or a hotel database to ensure a place actually exists. But even with these tools, the AI can still fail. Maybe it picks a hotel that's out of date, or suggests a restaurant that's closed. The study tracks these hallucinations to improve accuracy. This isn't just about better trip planning. It's about making AI reliable in complex tasks. By mapping errors and refining prompts, researchers are building smarter assistants that handle real-world chaos, whether it's navigating a city or avoiding a booking mistake. So next time you see an AI plan a trip, remember, it's not magic. It's a mix of clever coding, careful testing, and learning from mistakes. And that's what makes this research so exciting, because if AI can plan a trip, what else could it handle? Thanks for watching. If you like this deep dive, hit subscribe and let me know in the comments, what other AI mysteries should we unravel?